Now we're going to learn how and when to use something like PBr3 to convert OH to a halogen versus tosyl chloride to convert OH into a tosylate. In both cases, you're converting OH into a leaving group that you can do a nucleophilic substitution reaction on. So here, what we're effectively trying to do is convert this OH into something else, in this case, SCH3. And what we're looking at is having some leaving group. You're going to add the SCH3 nucleophile. That will add here. You'll lose a leaving group. Like this. But what you should notice in these two examples has to do with the stereochemistry. So in both cases, we're starting with a back OH. But how do we pick the appropriate reagents if we want the SCH3 group out versus back? So think about the net stereochemistry outcome. In the first, we have a net inversion. In the second one, we have a net retention of stereochemistry. For the net inversion, think about the SN2 step. So the SN2 step where we add the sulfur nucleophile, that's going to invert the stereochemistry. What that means is we don't want the stereochemistry inverted when we convert OH to a leaving group. We want the inversion to take place during the SN2 step. The tosylate is perfect for this. So what we can do is add the tosyl chloride and pyridine. This just adds the tosyl group to the oxygen without changing the stereochemistry. So it's still back. We have the OTS, and now we have this good leaving group. From here, we're ready to do the SN2 reaction. And I'm going to use just NaSCH3. So remember, when you see that, what it really is sodium plus and SCH3 minus. That's going to act as your nucleophile. That will come over and attack the carbon with the leaving group, and the leaving group will leave. So this is SN2, and remember, SN2 happens with inversion. So when this occurs, the SCH3 group ends up right here. It'll be out. Since your leaving group was back, the nucleophile is out. For the net retention, we can't do an SN2 step and just retain the stereochemistry. So in order to get this net retention, what we essentially want to do is a double inversion. So this works well with using PBr3 and PCl3. For this one, I'm going to start with PBr3, and you could use PCl3 just as easily. Remember that this goes through inversion. So the product of this, we're going to convert the OH to the Br, but the Br will be out because the OH you started with was back. Now we can do the SN2 reaction. I'm going to still add NaSCH3. And because this one is SN2, this also goes with inversion. But since we have the leaving group here, which is the Br, since it's out, and the SCH3 minus adds from the back, when we add this, it's going to invert the stereochemistry once again. So the Br being out means the nucleophile that added will be back. So what we have here is double inversion. which is the same as net retention. So depending on the stereochemical outcome you want, pick the correct reagent to convert OH to the leaving group.